Hi everyone, this is Miss Afric here, and today we're going to be doing our 8.3 notes where we're going to talk about the number e. Now I know that might sound strange calling e a number, but we actually do that a lot in math. We've got letters that actually represent numbers, so they're actually constants rather than variables. For example, we've talked about pi, right? That's not a variable, that's a number. It's approximately 3.14. Also another one you might remember from last semester is I. Even though it's a letter, we also know that it's equal to the square root of -1. Alright, so these are examples of letters that represent actual numbers, not variables. And that's what e is. Okay, what is the natural base e? E is known as Euler's number, after the guy who discovered it, Euler. And I know it's spelled Euler, but it's pronounced Euler. And e is approximately 2.718. Now the reason we call e a natural base is because it arises naturally in a lot of real-world situations. For example, one place you'll see e a lot is with compound interest, which we're going to be talking about a little bit later. So if you're someone who wants to go into finance or business, things like that, this chapter is going to be all for you. If you're not, oh well, you'll enjoy it anyway. Alright, let's take a look at some examples using e. We're going to get to the applications in a little bit, but first let's just get used to using e. So in example 1, we're going to be simplifying natural base expressions. So natural base, again, that's e. So expressions with e in it. It says simplify the expression. For these problems, A, B, and C, we're just going to be using our exponent properties to simplify it. I don't want you to type it in your calculator unless it specifically asks for an approximate answer in the directions. Here it doesn't, so I'm just going to use my exponent properties. Remember, when I have the same base and I'm multiplying, that means I take my exponents and I add them. That's one of our exponent rules. So e to the 3 plus 4, which is going to be e to the 7th. And again, I'm not going to type it in my calculator. The directions didn't say anything about giving an approximate answer. So e to the 7th, that's my final simplified answer. Alright, let's take a look at letter B. Letter B is similar, a little bit more difficult. 10e to the 3rd divided by 5e squared. So in this case, what you need to be careful of is notice how the base of these two exponents is really just e. The 10 and the 5 are not part of that base. So the 10 and the 5 I can just divide. 10 divided by 5 is 2. And then since I have e to the 3rd divided by e squared, same base, but I'm dividing, I can subtract my exponents. So 3 minus 2 would give me 1. Or you could also just write it as 2e. Alright, taking a look at letter C, it's a little bit more difficult, but we did just do exponent properties, and even more difficult ones because they involved fractions. These are just normal numbers. So let's have you guys try this one on your own. I know you can do it. Go ahead and pause the video for a little bit, work on the problem. When you unpause, you can take a look at my solution, see how it matches up. So go ahead and pause right about now. And we're back. Hopefully you paused it so you could try it on your own. It's really important that you try these problems on your own first, just to make sure you know how to do them on your own and not just from watching someone else do it. Alright, in this problem we distribute that exponent. 3 squared is 9. Then when I distribute it to the negative 4x, we got negative 8x. Remember, we can never have negative exponents, so I simply move that piece to the bottom, and that's how we end up with our answer. Alright, let's move on to example 2. Example 2, we're going to need a graphing calculator, so if you don't have yours out, go ahead and pause the video, take it out, it'll only take a minute. Alright, I've got mine right here, but I'm going to move it so that you can see it a little better. There we go. Okay, now this example says using a graphing calculator to evaluate the expression. So here we're definitely going to use our graphing calculator. We're going to get an approximate answer. Okay, to find the e key on your calculator, you want to locate the ln. That's close to e. We'll learn about that more later. But e is the little blue one right above it. So we'll do second ln. And feel free to write that down if you think you might forget where to find it. Second ln. Okay, and then we want e to the 3rd. Press enter, and there we go. Approximately 20.09. So approximately 20.09. Alright, same idea for letter B. E to the negative 0.12. So again, e is second ln. Now I've got oops, can't see that negative very well. There we go. Negative 0.12. Close those parentheses, press enter, and again, approximate answer. So approximately 0.89. So just make sure you're reading the directions so you know what type of answer we want you to give us. Alright, moving on to example 3. Example 3 that says, sketch the graph of the functions and state whether it's an exponential growth or exponential decay function. We've been talking about exponential growth and decay, so you should have some idea of what that graph might look like. In order to graph these equations, we're going to again use our calculator, so go ahead and pull that out one more time if you put it away. And for letter A, let's start with that one. So I'm going to go into my y equals, type that equation in, 5e, remember that's second ln, e to the negative 3x, close those parentheses. And then you might want to do a quick zoom 6 just to make sure you're in a good window. And let's get that graph going. Alright, it's a little hard to see, whoops, but you should be able to kind of make out a little line right there. If we try to sketch it out real quick, it should look something like this. And typically we'll read graphs left to right, so we should be able to notice that this is decreasing left to right, which means it is exponential decay. Decay would mean decreasing. Alright, for letter B, similar idea. We're going to go back into y equals, clear out this original equation, and type in our new one. So e to the, and I like to type it in exactly how I see it, so 0.4 parentheses x plus 1. Close those parentheses. Don't forget to close the extra set of parentheses around the whole exponent, and then subtract 2. And if I graph this one's going to be a little easier to see. Alright, there we go. So I can go ahead and sketch this on my paper. Should look something like this. And since this one left to right is increasing, this would be exponential growth. Alright, increasing, that's growing. So exponential growth. Alright, let's take a look at some application problems. So go ahead and flip your page over. You can see at the top of the page we got the compound interest formula. Now that's from the very first video and also a little bit in the second video where we talked about how we can find like a final amount that you end up getting in an account depending on the type of interest you've got. Well, today we're going to do some more stuff with interest, but we're going to talk about a new formula. Oops, there we go. And that's for a specific kind of compounding called continuous compounding. Let me just highlight that word because that word's important. A lot of people see it and think that means like, oh, continuous, that's just like every day. But no, that would be daily, right? Continuous means more than just daily. So we can't really put a quantifiable number to it. So instead, we just have a whole new formula that we use. And the basic information is still the same. So A is still our final amount in dollars. P is our principal, or I like to just call it the initial amount. But that's why we call it P, is because it's also called the principal. R is going to be our rate, and it should still be a decimal, DES, decimal. And T is going to be our time. So everything is still the same from the last few times we've used the formula like this. Oops, that shouldn't be there. There we go. Alright, so in this example 4, it says you deposit $1,500 in an account that pays 7.5% annual interest, compounded continuously. So there's that word that you should be aware of, continuously. That means you're going to use this formula up here. We like to call it the PERT formula, because it spells out PERT right here. I know, we're super creative. Anyway, so we've got this compounding continuously. We're asking what is the balance after 1 year. Well, let's go ahead and list the information we've got. If I'm depositing $1,500, that's my initial amount in the account. So P is equal to $1,500. Alright, and then I can see my rate is 7.5%. Remember, we want our rate as a decimal. So to turn it into a decimal, we just divide by 100. Or you can move the decimal over twice. Either way works. So we should get 0.075 as our rate. And time, well, it wants the balance after 1 year. So time is just going to be 1. Plug our information into our formula, and let's solve for that balance after that year. So A is going to equal P, which is 1500, times E. Remember, E is not a variable, it's a number, so we're going to leave that E, to the 0.075 times 1. Now I'm just going to go ahead and type that in my calculator. Quit out of this graph. So I've got 1500 times E, which is second ln, to the 0.075 times 1. Enter. And there's our final balance. And it should make sense that it's more because we are earning extra money. We're earning interest. So our final answer is $1,616 and about 83 cents. We'll round that up. So 1,000. Don't forget your unit. In this case, it's just dollars. $1,616. And what was it? 83? Yep, 83 cents. With dollars, we'll always round to the nearest cent. So that's one of the biggest examples of an application of using E, is a lot with that compound interest. Alright, looking at example 5. Example 5 says the atmospheric pressure P in pounds per square inch of an object D miles, notice how it's miles, that's going to be important, above sea level can be modeled by this equation. I love it when they give you an equation in a problem because it's kind of like they're telling you, well, whatever information we give you, just plug it in. Makes it a lot easier. Alright, A says, how much pressure per square inch would you experience at the summit of Mount Washington, 6,288 feet above sea level? Uh-oh, we got a problem. This is in feet, but we know that in the formula, D is in miles. So I'm going to have to do a quick little conversion. Just so you know, there are 5,280 feet in 1 mile. Long way, I know. So to convert this, I'm just going to do it off to the side here. 6,288 feet. In 1 mile, there are 5,280 feet. So over here in my calculator, I'm just going to do 6288 divided by 5280. And we got approximately 1.19 miles. So now all that's left to do is to plug it into our formula. P is going to equal 14.7 E to the negative 0.21 times 1.19. And this you would just type straight into your calculator. So if you did, and I would suggest trying it to make sure you get the same number as me, you should end up with a pressure of 11.45. And don't forget your units. P is in pounds, oops, not ponds, pounds per square inch, per inch squared. So there's my answer. Alright, letter B is a little more interesting. Letter B says graph the model and then estimate your height above sea level if you experience 13.23 pounds per inch squared of pressure. So they're telling us our P value is 13.23. To graph the model, I would just use my calculator. Alright, so I'm going to let you guys go ahead and do that one on your own so that I can get to the slightly more difficult part. Alright, use your calculator, give it a good sketch. But in order to estimate the height here, we're going to plug this into our equation. Let's see what we end up with. So 13.23 equals 14.7 e to the negative 0.21 d. Now, this should look a little familiar because in the first couple of videos, we did a few problems like this, and remember, we talked about how we don't have enough tools yet to solve this equation by hand. So, in order to solve this, we're going to use our calculator, and we're going to type this into y1, and this other side into y2, and then we're going to find that intersection point. Alright, and you can always solve equations like this. Usually it's just a little faster to do it by hand. But since we can't do this one by hand, we'll have to use the calculator. Okay, now I'm running out of time, so I'd like you guys to try this one on your own. I've given you enough tools for you to have an idea of what you should be doing. So go ahead and figure out what that D value should be. And in class, your teacher will ask for it the next time you see him. So don't forget to do that. Okay, that part is all you. If you still have questions on anything we did today, watch the video again, write down your questions, make sure you're kind of getting a good summary of what we just watched. Otherwise, we'll see you in class the next time we meet. See ya!